Okay, we're on the examples and we'll do them. Okay, so first example is use the definition of logarithms. Let me just point out what I mean by that. If you have a log base A of some number x and that equals y, we can rewrite this to say that x is equal to a to the y. This with the understanding that a is a positive number. All right. By the way, we don't like a to be 1. Okay. So let me look at this problem and I'll see if I can do it. We'll say log base 10 of 100. And they want me to evaluate using this definition that we have for logs over here. So I'm going to simply say, I don't know what it is. So what I do, I'd rewrite it. How would I rewrite it? I want to point this out to you. It's going to be the base raised to this. So we have 10 raised to the power x will equal the argument of x. Let's write this down. Again, I know I'm mixing up letters here. Like you say x there, also next here. It's the principle. A to the y is equal to x. And write that down for you. 10 to the x is equal to 100. Now, what did I do? I took a log problem, which was unfamiliar to me, and I'm writing an exponential problem, which is much more familiar to me. If it's more familiar to me, I'm going to say probably have a better chance of doing this one. And what does this look like? Well, x has to be 2 because 10 squared is 100. So I'm going to get my eraser out. I'm going to erase this over here and put 2 down and say I'm done. Is that the answer they're listing? Of course it is. It'll be outrageous otherwise. Let's go to the next page. And next page, oh, by the way, they do point out their SAGE code for this one as well, for those students that want to look at the SAGE code. But let me look at this one over here. And as I'm doing it, I'm going to evaluate each one. And I'm going to say they should be simple to do, right? Provided you know those, what the log means. So I'm going to do one at a time. And when I write this down, I'm going to write down, this means log base e of the number a. And I'm going to say, I don't know what it is. So if I said that, what would I do? I'd write it as an exponential problem. And what would it be? E equals e to the x. Certainly looking at that, I know x is 1. So what do I know now? The natural log of e is equal to 1. And certainly I'm seeing that in the k. Let's go to the next one. And as I do that, I want to point out what I'm doing is the same thing over and over again. And I really want to emphasize that what I'm doing is just rewriting them. So this is really log base e squared. And I'm going to say, I don't know what it is. Right? What I do right is an exponential. So the argument e squared would equal e to the x. Well, what do I now know? I know x has to be 2. So what's this mean? The natural log of e squared is equal to 2. All right. Again, if you're looking at these things, the key says that as well. There's no surprise there. Now, I think I'm getting a little better at this. I'm looking at this one over here. I probably do this in my head. I'm going to say this is the it's almost the same type problem would be 3. All right. Let's look at the k and make sure it said that. Again, I did 2 examples and I'm seeing that and it seems reasonable. Again, if you want to write it exponentially, you can. Now, this one should seem reasonable to you too. What am I going to say over here? This would equal n. All right. Would equal n. So what am I going to do over here? Check it. And lo and behold, they got n over there. Let's do this one over here. Very similar problem, by the way. And again, it's not the natural log, it's log. And I want to point out what log means to me, at least at this level of the game. When someone writes down log at this level of the game, it means base 10. I'm going to say, I don't know what it is. As an exponential, what I get? Well, the argument, which is 10, equals 10 raised to the power x. Well, x has to be 1. So what am I getting over here? Log 10 is equal to 1. Again, you look at your key, you got that. Again, I'm getting a little better. I could look at this and probably say, oh, this has to be 2 then. Again, you can write as an exponential if you want, but you should be getting better at this. Let's go to the next page. Make sure it does say 2 in the next page. And it does. All right. So I feel pretty good about that. Next one up. I just blow this up a little tiny bit. And I'm going to look at it. And I'm going to say gee whiz 3. No surprise there. Gee whiz n. No surprise there. All right. This one's a little more complicated. And when I say it's more complicated, people say, why do you think that's more complicated? I'm looking at it. I'm wondering, what does this mean? Right. So I'm going to write it on the side. And I'm going to just remind you that rules of logs I have over here. So I'm going to put down log base a of b equals c. Yeah, I'm kind of moving letters around. What does that mean? Well, it means b equals a to the c. So I'm going to point out that I can go back and forth in any direction I want. So let's write this one down, see what we have. All right, so I'm going to write it down, and I'm going to write down, again, this what we're doing is e to the ln 2. All right. And what I'm going to do is, I'm looking at it and I'm wondering, is it related to what we were just given? And I'm going to say it does look related. And let me point that out to you. I'm getting a power. You see that? I get this over here. Now, what I want to do is I want to go in this direction. I'm going to rewrite as a log, see if I can figure that out. Yes, it takes a little bit of effort. Some people are better at this than others, It's almost like looking at a foreign language. Some people are good at it, some people aren't. And I'm going to say, gee, I'm going to call this, I don't know, I'd call it X. And let me see if I can go back to write it as a log then. And what would that be? Let me see if I can do that. So what would I get? I'm going to say the base is definitely log base E now. All right. I'm seeing that backwards part. All right. And then, of course, what's the argument? The argument would be X. And what's going to equal? Well, the natural log of 2. Yeah, I know that's tough. What's X? Well, I hope you understand natural log of V is just natural log like that. What's X have to be? Well, I hope it's clear. X has to be 2. Let's check it. And we got 2, right? Exactly what we expected to get. All right. So, number 3, let me read it to you. And again, it's really kind of a repetition, and repetition's helpful sometimes. Sometimes it's not helpful. It's like just you say the same thing over and over again. Yeah, we kind of do. They say write the exponential equation for this one over here. And this is log. Again, doesn't matter what letters you're using. Base A, argument is B is equal to C. Well, that's fairly easy to do. What does it say? B is equal A to the C. Same thing. All right, let's keep going. And this is number 4 now. And again, what am I doing? I'm going to try to write it so I can understand it. Logs are new to me. So I'm going to put that down for you. And what do I put down? So I'm going to write this as an exponential, right? Sorry about that. I should go back to black. I'm going to write as an exponential. What do I have? I have 3 is equal 9 to, oh, I'm sorry. I'm looking at the answer. I should look at the question. I apologize. Let me erase that. That's crazy. And I'll point out what I'm looking at. I'm looking at the question. It says use a definition to evaluate log base 9 of 3. I'm going to simply say, I don't know what it is. I'm going to call it X. Call it anything you like. I'm going to write it as an exponential. What's going to be? 3 would equal 9 to the X. All right. I like to write things in the same base, but don't feel obligated to do so. When we go here, I'm going to say base 3. So what's 9? It's 3 squared. So it's going to be 3 to the 2x. All right. So I'm looking at that. I'm wondering what's the exponent on the 3 to the left? It would be 1. So what does this tell me? 2x has got to be 1. What does that mean? X is a half. All right. What does it mean? Log base 9 of 3 equals 1/2. That's written over here. I want to check this though. And I want to write down what this means to me. This means 3 equals 9 to the 1/2 power. Well, you should know from math 100 the half power means the square root of 9. Well, what's square root of 9? It's 3. Makes pure sense. Let's go to the next thing, which number 5. Now I realize for number 5, I do provide you a graph, and I think it's a good idea to use that. Before I do it though, I want to see if I can make some attempt to understand what we're talking about here. All right. And what I'm going to do, I'm just going to look at log base 2. And I'm wondering what numbers would be easy for me to do. What numbers would be easy for me to do? And what I'm going to claim over here, I'm talking about these numbers. What numbers there are easy to do? Well, I'm going to write it down as, I don't know. I'll just call it X. And I'm going to call this thing over here Y. So the numbers that are going to be easy to do is where X equals Y squared. All right. I'm sorry. I made a mistake there. I'm daydreaming. And I realize I'm daydreaming. Let me go backwards. I'm sorry about that. Is 2 to the Y. So what I'm going to claim is the X's should be, powers of 2. So I'm going to start writing those down for you. I'll put the x down. I'm going to put powers of 2 down for you. Yeah, I'm going to say easy ones would be 2 to the first power, 2 to the second power, 2 to the third power. That's 8, isn't it? And then 16. They're just doubling. They're really easy to put down. And I'm going to claim they're going to be easy to put down. Now, what's another number going in the other direction? I would say 1. What's that? 2 to the 0. Then 2 to the minus 1 is a half, so forth and so on. And let me write this down. Log base 2 of x. Let's see if we can do that. And I really want to see if I can do it. And, I'm going to say over here, log base 2 of 2 would be 1. Log base 2 of 4 would be 2. Log base 2 of 8 would be 3. Log base 2 of 16 would be 4. All right. Okay. Log base 2 of 1 would be 0. Log base 2 of 1/2 would be -1. These are really simple numbers, and we want to stick with those simple numbers. Now, someone says, why is that? Because they're simple. They're easy. All right. So I'm gonna start to erase a little bit, not a lot. Erase this over here. And what I'm going to do is I'm going to pull this on the side. And I know it's tough. I'm not saying it's going to be easy for you. I want to start talking about easy numbers for the x. And this can get tough. Now, someone says I want to do this by translation. We're not opposed, right? But I want to talk about easy numbers. And this is kind of what we did, back in the day when we had translation. We looked for easy numbers. And I'm going to write these down for you. All right. So I want to do this one over here. And I'm going to do a nice, easy table for you. And this is going to be f of x over here. And I want to point out what we're doing over here. I'm wondering, I'm going to underline this for you. When this becomes these easy numbers over here. Well, let me kind of do one number at a time. Just one number at a time. And what I'd like to do is, I'd like to just concentrate on the 1. When would that argument become 1? When x is 0. That's easy. When will it become 2 at -1? When would it become 4 at -3? When would it become 8 at -7? I think you get the idea. When does it become 16 at -15? That's not bad. Now, when does it become a half? Well, 1 minus half would be half, right? Now, somebody will say, could you keep doing it? I could. And I want to write down the next one for you. I'm going to get my eraser out. And let me just do that for you. Erase this over here. I'm going to extend my table. And I know this is a learning curve for a lot of students to be able to work their way backwards. So it's going to be x. This is going to be log base 2 of x. Well, what's the next number going to be? A quarter. That's going to be -2. Then an eighth. That would be -3. Yada, yada, yada. All right. I know it's tough. I want to concentrate on it, though. I want to concentrate on this and this. We'll talk about how to evaluate this thing later. We'll get to the graph in a few minutes. All right. Let me take a look at this. And what I'm going to do is I want to point something out to you. And my question is, I want it to be a quarter. So we'll go over there. That had to be 3/4, right? And I want to do the next one. It's really tough, but we can do it. And I'm going to point out what we want to do. We want it to be 1/8. Well, that would be 7/8. Okay. I know it's tough. And my claim over here, it's for some students, it's so tough, they need to take a break while doing it. But I want to keep moving forward. And I'm going to start to erase this business over here. And I'm going to write this down for you. And I'm hoping when I write this down, it's easy. If it's not easy, we're doing the wrong thing. It's going to be 1 minus 1/2 log base 2 of something. Every single one's going to look the same to me. Every single one is going to look the same to me. And when I say that, the form of it, the numbers are going to change. And why is that? The x's are changing. Oh boy, I got some more to do, don't I? And by the way, I notice a lot of work. Some people say I can't do all that work. You're going to try. All right, let's do one thing at a time. Let's do minus 15. What's 1 minus a minus 15? It's going to be 16. I'll do the arithmetic later. When I do the, I'm going to, evaluating the log and doing that arithmetic, like minus 1/2 of it and adding 1 to it, right? So I got minus 7, right? What would you get up here? 1 minus a minus 7, that would be 8. All right. All right, let's keep going. I know it's difficult. Minus 3. What do you get? 1 minus 3 is going to be 4. Well, I get the idea. What's the next one going to be? 1 minus a minus 1, which is 2. Next one's going to be 1.
I found this on the web.
Whoops, I touched Siri. That's what happened there. Sorry about that. She's trying to do my arithmetic for me. So what do you got? You got a half. What's 1 minus half? A half. Okay. What's 1 minus 3/4? 1/4. What's 1 minus 7/8? 1/8. All right. I think I'm ready to do some arithmetic here. And I want to point out, yeah, it's new to me, but I think I can figure it out. 1 minus 1/2. What's, 2 to what power gives you 16? Well, 2 times 2 is 4, 8. Oh, 4. That's easy. What does this give me? 1 minus 2, which is minus 1. All right, I'll write that down for you. Let's do this one. 1 minus 1/2. Well, what's log base 2 of 8? That's going to be 3. So what do you go there? 1 minus 3/2. Now, what does that give me? 1 minus 3/2 is going to be minus 1/2. Again, I'm just trying to figure things out. 1 minus 1/2. Well, log base 2 of 4 is going to be 2. And what's that going to give me? 1 minus 1, which is none. We'll look at our graph later. 1 minus 1/2. Well, log base 2 of 2 is 1. So I get 1/2. All right, let's do this one over here. 1 minus, well, that's going to be 1/2 times 0, right? Which is just 1. That was simple. And by the way, there's certainly a pattern to these. All right, let's write this down. 1 minus 1/2. This would be minus 1. What's that going to be? 1 plus 1/2. All right. What's this one going to be? 1 minus 1/2. Well, that's going to be minus 2 now, right? And what do you get over there? I'm sorry, I forgot to do this one. There's going to be 3/2. What's this one going to be? Well, 1 plus 1, which is 2. Right? I'm going to go too fast with that. What's this one give me? 1 minus 1/2 times minus 3. What do you get over there? 1 plus 3/2. What do you get over there? Well, I forgot to fill this out. Sorry about that. 3/2, 2. And this one's going to be what? Let's see, 5/2, right? All right. Now, sometimes I still don't know what's happening. I want to claim, though, that something's happening in the problem. Right? Something's happening. All right. So kind of looking at it, I just want to look at the x's. And I'm going to say, if I kept going in this direction, I hope you realize this is going towards minus infinity. If I kept going in that direction. Trouble a lot of students have, though, is going in the other direction and wondering where this is going. And where's it going towards? If I kept going, it's actually going to go towards the number 1, but it's never going to reach it. It's never going to reach it. All right. Now, if I say it's never going to reach it, what side does it approach from the left of it? I want to tell you, though, that really the quick way to do that is to realize that the argument, this guy over here, 1 minus x, must be greater than 0. What does that mean? Well, if you solve that, what would you get? You get this, which means the x has to be below 1. All right. Let me go to my picture, and we're learning. And by learning, what we're doing is we're looking at the picture. I'm going to pull this picture on the side. And I want to just pull it on the side. I want to look at my table. Just give me 1 second to do so. I'll put this over here. I'll push it over a little bit. All right, let's go through one thing at a time. I'm going to circle what I like doing now. I pointed out. I want to do this one over 0, 1. I think it's the easiest one to do. All right, see, I'm going to plot the point. And just plot this point right over here. What's another easy point for me? By what I mean easy, I mean easy. I'd say this one. I get that point. I want to do this one now. I know it's hard, it's more difficult. It's -1 and then a half up. All right. Now, someone says, do you want to do the other ones? You know, not really, because I'll be honest with you, I think I know the pattern now. I think I know the pattern. So if I want that to -7, it's going to drop down to -1/2 over here somewhere. And not that I want to plot that, but I hope you realize it's over here somewhere. Right? And then if I want the -15, it would go to -1. And I'll put that over here. That's kind of even hard to visualize, isn't it? But I think you probably know, just connecting it together now. And I'm seeing this over here, just connecting it. I'm seeing something like this. And what's it going to be doing? It's going to continue to go down, although slowly, it continues to go down, although slowly. Let's go in the other direction now. It's tough. And we'll take a look at it. And we'll see what happens. And this takes effort on your end. So let's look at it. And let me go back to red ink. I'm going to do the 1/2, 3/2. And I'm going to say that looks 3/2 about here and half, right? That's tough. And then 3/4 too. That's about right about here. And then 7/8, it goes up to 2.5. I think you get the idea. And what are we getting the idea? How things connect together. All right. So let me get my my green ink and I'll connect these dots together. And by the way, when I say that, I know it's tough to wonder what's happening to this picture over here. But remember, we said the x had to be below 0. And I'm noticing that. So what am I noticing over here? An asymptote, and this asymptote is x equals, I'm sorry, I said x has to be below 1. If I misspoke, I'm sorry. X has to be below 1. What am I seeing now? Asymptotic behavior. This thing's shooting straight up. By the way, if you don't see that, you have to pick out more points in the table, but it's really not so bad. Right? We got a picture of it. And I want to go back to the question and see if I've answered the question. And we'll take a look at the question now. Where they say graph it, we did that. Be sure to indicate any key features on the graph and the asymptotes. I want to point out what the key features are. And I want to go back to the graph and point out what they are. The x and y intercepts, the asymptote. These are key features. This is x equals 1. This is a very simple point. The point is going to be 0, 1. This was also a very simple point. It was -3, 0. So I'm going to say they're definitely the characteristics of it. The other thing is the general shape of it. And I can't say we actually do a good job of that, but a machine does. The general shape of it. It looks like a log function. Goes on forever, and it goes down forever that way, although slowly, by the way. And by the way, to the right, it goes up very quickly. It's always increasing, by the way. All right. Your graph should look relatively like mine. Now, here's another problem for you. I know it's difficult. All right. I do want to look at the picture. Before I look at the picture, though, what I want to do is talk about the function. And what I know about this function over here is just looking at it. I'll write this down for you. Y is a function of x. And what is it? It's 12 times the natural log of x squared plus 1 over x minus 2. So I'm going to claim over here, just looking at it. I'm not even looking at the graph yet. I'm going to say, just looking at this function over here, there's trouble at 2. Why is that? Division by 0. So I'm going to say trouble at 2. I know there's trouble there. All right, we'll look at the graph later. But what I mean by that, they want you to use a graphic utility. And I'm going to say basically, you know what, you probably should be using a computer to do that. But before I get to the computer, I want to see if I can understand what I got. All right. So x equals 2 is definitely trouble. I'm expecting to see asymptotic behavior at the 2. Right. So I'm going to say that's definitely true. Now, what else do I know about that? Well, I know the log, I'll write this over here, the log, this is natural log of x squared plus 1. I know the argument, which is x squared plus 1, must be greater than 0. And here's the deal. Is x squared plus 1 always greater than 0? Of course it is. So this log has no troubles on it. So the domain of that log is all real numbers, but still I got trouble. I can't use 2. So let me write this down for you. I'll write domain down now. So domain is all the real numbers except minus 2. Let me repeat this. I looked at the log. Log argument must be positive. I wrote that down. This is always positive, but there was one number that was dangerous on the bottom, and that was 2. Now, what does that domain look like to me? It looks like this. Minus infinity up to minus 2, union minus 2 to infinity. We'll look at the graph later. So I got the domain down. I may not know what it looks like, but I do have the domain down. All right. What else am I going to do? I'm probably going to look for the y-intercept. How do I get a y-intercept? Set x to be 0, right? So set x to be 0. What do you get over here? 12 times the log. When I say log, that's natural log of 1 over minus 2. What do you get there? You get 0. Now, someone says, why is that? Well, the natural log of 1 is 0. And what's 12 times 0? 0. What's 0 divided by minus 2? It's 0. So I got a y-intercept. What's a y-intercept? 0, 0. By the way, it also happens to be an x-intercept. But is there another x-intercept? And the question is the argument ever equal to 1? In other words, is x squared plus 1 ever equal to 1 at only one spot when x is equal to 0? So there's only one point now. This is both an x and a y-intercept. So if I were to draw this thing down now, and we'll go to the next page later, what would I see? I would see a graph with one lousy point at 0, 0, an asymptote, at least I believe an asymptote, at minus 2. Write that down over here. Now, granted, I'm going to say there's other things you could look for. For example, you could look for, horizontal asymptotes, but I don't think we're ready for that yet. So what we're ready to do is answer some of the questions. And let me point out what we just answered without even going to any utility. So let me just point out what we've answered. And I'll get my little highlighter out. Have we done the x and y intercepts? We have. They're right here. 0, 0. Any asymptotes? Well, to be honest with you, the only one I really could do at this point one is probably the vertical asymptote. Have I done that? Yeah, let me write that down for you. And the vertical asymptote, whoops, sorry about that. The vertical asymptote is x equals minus 2. All right. So what I'm claiming over here, this is tough. So what I want to get to is I want to get to using a machine. So what I'm going to do is I'm going to switch screens. And just give me a moment to do so. And I'm scrolling around. Oops, I think I'm in the wrong section. Yeah, I am. Oh, there's the picture. And I want to tell you how I generate the picture. And you can use Sage. I don't mind using Sage or your calculators or your cell phones. I'm going to go to an application called Grapher, and I'm going to graph that out. All right, let me put this down for you. There's also Sage code there for as soon as I want to use Sage. What am I going to do? Well, I'm going to graph. Let me pull this aside so you can see it. 12 times the natural log x squared plus 1. Yep, you have to learn to type. Divide by x minus 2. All right, what do I see? I don't see the whole picture. So what I'm going to do is I'm going to zoom out. And I could do this all, you know what? I think I said something. Oh, no, I didn't say anything wrong. So I'm going to put the asymptote in. Let me put that down for you. What's the asymptote? I'm going to say x equals 2. And what I'm going to do is I'm going to make that a dashed line now. Give me 1 second to do so. I'm also going to make it red. Make it magenta. All right. So this is, part of learning software. By the way, I want to get rid of the grid because it's kind of disturbing me. So I'm going to do that. And I'm going to just simply get rid of the grid. I'm going to get rid of the frame. And what I want to do is I just want to, select this thing over here. I just want to zoom out. I want to see what happens when I zoom out. So as I zoom out, I think you probably can appreciate that this graph appears to be asymptotic with the x-axis. So I'm going to claim there's a horizontal asymptote without going through limits at 0. All right, and would that be y equals 0? So I want to go back to this picture over here that we're providing for you. Again, what did I do? I graphed it and I zoomed out. And I start to notice that these lines over here are going towards the x-axis, which means a horizontal asymptote of y equals 0. We didn't do a limit though. We're looking at a picture, by the way. All right, so let me go back to my whiteboard. Give it a second to warm up. And I want to go to the next page. Oh, I know what I did on here. I made a mistake. And I said x equals -2. And I have to correct that. And I'm not sure why I said that. So let me erase this over here. My memory kind of remembered doing that. So what I do, I said we had a point, and then I said the asymptote was -2. It's not. I keep writing it down. I got to put this +2. Let me go through that with you because I did make a mistake. It's when the bottom becomes 0. And I made a mistake over here, and I made mistakes all over the place. That's +2. This is +2. That's +2. And I apologize for that. So it's x equals 2. All right, so let me put that down for you. And what is that going to look like? That's going to look like this over here. Okay, so let me go to the next page. And I know I made a mistake there. And again, I apologize for making that mistake. All right, so we got a picture over here. What I got my picture, I got this part here. And I did get this part, the asymptote, although I did make a mistake initially. That's x equals 2. The x and y-intercept again is just simply 0, 0. What do I know about this function? Looking at it after using technology, we didn't do analysis beyond that, right? Looks sort of like this. We use technology. And this one, again, I really, this would have been really tough without knowing some calculus to do that. It looks like this over here. Now, someone's going to say, what else could you answer about that question? And I'm going to go write these things down over here. Certainly we got the domain of it. That was -infinity up to 2, union 2 to infinity. We got the x and y intercepts. That was 0, 0, 0, 0. All right, you got the domain. I guess we could put range down now. This is tough. All right, I want to put the picture. I think you can agree it goes down forever and it goes up forever. Now, if you look at this thing over here, it's just simply all the positive numbers. That's all it is. So I'm going to say it's a horizontal asymptote, and I'll put the vertical down. That's x equals 2. I'll put the horizontal asymptote. And again, just looking at a picture, y equals 0. I'll draw that picture in for you. And I want to see if I can put the range down. Range is more difficult though. Again, let me repeat this over here. It goes down forever, it goes up forever. Over here, it covers all the positive numbers. We're talking about the y values. Over here, it covers all the negative numbers and 0. So what's the range? It's all real numbers. How do you write that in intervals? Minus infinity to infinity. What do we need to do that problem? We need technology. Again, for students wishing to use Sage, this is the Sage code over here. And you can do that. And we've gone over that many, many times. All right. There's a new command over here, detect poles. What's it going to do? It's going to draw in the asymptote at x equals 2. It'll do that. All right. Let's go to the next question. It says evaluate the logarithm using the base change formula. Let me remind you what that is, and I'll go through it in stages with you. The base change formula is log base a of x equals y. What we do, we rewrite this as x equals a to the y. And what we do is we can write this to different bases. So for example, I could log base 10 of x would equal log base 10 a to the y, all right? And I can write down log base 10x equals y times log base 10 of a, and I can solve for y. And what do you get? Log base 10 of x over log base 10 of a would equal y. And that's a base change formula. I'll write that down for you. So log base 10 of x over log base 10 of a. You could also use natural logs. Why do I use log base 10? Your calculator has it. Why would I use the other log? Well, the calculator also has natural logs. So I could write this as natural log of x over the natural log of a. All right, either one. So let's write this down. So we have log base 11 over 4. Now, most calculators don't have log base 11. So what I would say, you could use log base 10. So it's going to be log base 10 of 4 over log base 10 of 11. Or you could use the natural log of 4 over the natural log of 11. My recommendation is you probably should use technology to do that. Now, what I mean by that, you go to Sage, you type it in, you can do the log 4 divided by log 11 or a calculator. Again, if you have trouble with that, and again, I'm going to use natural log because it's easy to write down. If you did log 4 over log 11, I'm going to go to the computer to do it for you, though. And I'm going to use Sage. And just give me 1 minute to do so. And we're going to go, and just give me a second. I got to do something to work around over here. Just give me 1 minute to do so. And this is something that you can do in Sage too, either online or if you have it installed on your computer, you could do that. And let me just, I want to do the computation and show you what happens. All right. So let me shoot another share. And I'm going to share a terminal with you. All right, we'll talk about this over here. Now, by the way, I want to point out in Sage, log is log base e. So let me put that down for you. Now, what's log base e of e? It should be 1, right? And I get 1. I'm expecting that. Now, if you did log, and that means in mathematics, upper level mathematics, it always means natural log, like e squared. What would I get? I should get 2. And I do. But if I type in something like what I want to do, log, it's going to seem strange to you, log 4, and I want to divide by the log. Again, remember, log in Sage means ln, natural log. And that's true in mathematics in general. If you do this, you're going to be shocked. It doesn't do it. So you need to force it to do it. And I want to tell you how to force it to do it. I'm going to say one of the easiest way to force Sage to do a computation is to give it a decimal. And I'll do that. And what I'm going to do is, what's it going to do? It's now going to say, oh, you want a decimal. You want me to do the arithmetic. What does it give you? Well, it gives you a level of precision, but I'm only interested in, 3 places, and that's going to be 0.578. All right. So let me go back to the whiteboard. I'm done with that. I'm going back to the whiteboard now. Okay. So we just verified this. All right. Let me repeat this. In Sage, log is the natural log. right, let's go to the next page. I think it's the next page. Yep, we just did 7. We're going to go to 8 now. And what's 8 say? Oh, it's getting back to easier things for me. It says use the definition of logarithm to evaluate this. Well, let me write this down for you. It looks pretty easy to do. And I'll write down, so it's log base 2 of 8 equals x. No calculator here, by the way. What does this mean? 8 equals 2 to the x. And I'm going to write in the same base. What's 8 base 2? It's 2 cubed. 2 to the x. What does this mean? X has to be 3. So what's log base 2 of 8? It's 3. Exactly what we expect it to be. It's 3. Exactly what we expect it to be. All right, use the base change formula to do this graph over here. What are they asking you to do? Basically, use a base change formula to graph this guy over here. So what would I do over there? And again, they want me to use a graphing utility, by the way. I want to point out where that's written for you. And again, the reason I say that, a lot of people, they don't read and they say, oh, this is a really tough problem. It shouldn't be. Use a graphic utility, but use a base change formula. Now, someone says, why would you do that? Most calculators do not have a log base 4, where they have either log base 10 or log base e. I'm going to write down log base 10 first. This is a base change formula. Excuse me 1 second, I made a mistake. So you could use log base 10, that's log 10, x minus 1 over log 10 of 4, or you could use the natural log of x minus 1 over the natural log of 4. All right, these are written down for you. I want to say, maybe I should go to the graphing utility, and maybe I should just do Sage for this. And I'll emphasize that I'm going to switch the notes to, I'm sorry, I'm going to switch screens now. And give me a second to do so. And I'm going to scroll to that. I think we just did this. We did that. And we're on this problem over here. So what I want to do is I want to open up Grapher. And I'm going to graph that in. And what am I going to graph in? And I'm going to graph in y equals. Now I'm going to type in log. I'm not trying to confuse you, but Grapher log is base 10. All right, I'm going to show you the same graph, by the way. X minus 1 divide by log 4. Now I'm going to show you this is the same exact graph. Whoops, I made a mistake in the typing. And I'll correct that. And I'm going to get rid of this thing over here, delete it. And I realize I don't like I'm going to equalize the axes, center the origin, and I'm going to zoom in. All right, so I got this over here. I'm going to pull it around, make it a little better. And what I want to do is, I know there's an asymptote there. I'm going to put that in for you now. And this is going to be a new equation. And that equation is going to be x equals 1. All right, I'll put that down. Definitely asymptotic with that. Now I'm going to just, zoom in. And someone says, why do you want to zoom in? I want to see if I can. And I'm just going to do this over here. And I see it now. All right. I got a better picture. At least I believe a better picture. You can play around with this if you want. I'm going to change the asymptote. Give me 1 second to do so. I'm going to make it a dashed line. And give me a minute to do that. And you should learn how to use software that you're comfortable with using. Don't think that someone's going to say, oh, you have to use this software. Now, if you go to NJIT, they're going to say, oh, you have to use MATLAB. You use what you like using. Now, granted, that might be hard because if you work for somebody and they say you have to use this application, well, that's when you're working for somebody. You're working for yourself now. You come to get educated. What I want to do is I want to graph something else. And what I want to graph out is, I'm going to graph out the natural log, ln. Now, one thing nice about Grapher, log in Grapher is just like it means for us in class. It means base 10. And ln in Grapher means base a, x minus 1. And I got to divide by the natural log of 4. As soon as I wonder what happens. Now I'm going to turn this off. I'm going to turn this off. I'm going to turn them on now. On, off, on, off. I hope you realize they're the same exact graph, and that's important. All right, let me go back to the notes. And when I say notes, the whiteboard actually. Give me a second to warm up. Okay, back on there. Let's take a look at this one. This one says expand it. And we have rules for logs. And I'm going to expand this over here. So one step at a time. And what do I see? I'm going to say, I definitely see log base 7. I'm not concerned about that, by the way. And I see a quotient. What's it going to be? X squared times y cubed minus log base 7. Whoops, that's a crazy thing I just did. Log base 7 of Z4. By the way, I definitely expanded it, but I want to go further. So it's going to be log base 7. I'm going to use a product. It's going to be x squared plus log base 7 y cubed. All right, so I did divisions and now I'm doing multiplications. I'm using all the rules that I know about and were presented in lecture. What I'm going to do now, the exponent rule, what would you get over here? 2 log base 7 of x plus 3 log base 7 of y minus 4 log base 7. I did it again. I got z in my mind of z. This is the most expansions I can do right over here. Is it the same as they have over here? Well, let's just check it. I'm seeing 2 log base 7x, 3 log base 7y, minus 4 log base 7z. Not bad. Let's go to the next one. And by the way, the graph is the graph we just discussed on the in the notes. Ooh, condense. What's nice about condensing? I'm going backwards now, and let's do it one step at a time. So term by term. First term, log base 10. Not going to write that down because it's not written down. X to the 5. Again, we're not trying to confuse you, but at this level of the game, typically log means base 10. All right. In upper level mathematics, though, log means base A. I know that's confusing. All right. Minus, what do you get over here? Log base 10 y cubed. Let's keep going. What's next one going to be? Plus log base 10 z to the 1/2 power. So what I'm going to claim over here, just looking at it, I realize I got a division and a multiplication, and I'm going to do that in one shot. What do you get over here? Log the multiplication, which is x5 times z to the 1/2 power, all over y cubed. Again, I want to point out that in the notes, I'm writing z to the 1/2 as the root of z. I don't mind. Either way, I have it written down, but they're the same to me. All right, we got it. All right, consider the following. Now, someone says, why would you do this to me? Well, what they want you to do is use a graphing utility to graph both of those. All right. Before you do it, though, I want to point out that just by a manipulation, if you were to manipulate it, condense or expand these guys. So if you were to condense or expand these guys, they would look equivalent. They would look the same. But the question is, are they the same? That's what they want you to do. So I'm going to switch to the computer system. I'm going to switch now. And give me 1 second to do so. And what I want to do is I want to graph these guys out. And again, I'm not going to say it's easy for you. I mean, if you're not following along with the technology bit, this might seem really strange to you. But I'm going to, go back to Grapher because I like using Grapher. And what I want to do is I want to graph these guys out. So I'm going to just delete it. I'm going to delete this guy over here. And I want to graph this guy out of here. So I'm going to say that's going to be 2. And then I see parentheses, natural log of 5. I see that. Pretty easy to do. Plus the natural log of x squared plus 1. Whoops, sorry about that. Plus 1. And I'm going to graph that out. And I'm going to just pull this up a little bit so you can see better. I'm going to equalize the axis. I'm going to center the origin, and I'm going to zoom out. And I see it. And I'm glad I see it. All right, because I didn't see that, I was wondering where it is. I want to graph the other guy out though. And someone says, how do you do that? Well, I'm going to do it. I'm going to see what happens. And when you say the natural log of 25 x squared plus 1 squared. All right, let's see what that gives me. Now, someone says, I wonder what it gave me. Let me just turn it off and turn this one off. It gave me the same curve. So the condensation or expansion would give the same result, right? The condensation or the expansion would give the same result. And that's important. Not always true though. So I want to just simply go to question B over there. And it says over here, are the graphs identical? And the question is, are they identical? They're identical. So the condensation and expansion in this particular case yielded the same result. Does it always? No. And that's what you need to be concerned about. There'll be a homework in the supplemental stuff. We'll be able to see that as well. All right. So I think that's about it for the examples. Please keep continuing to move forward. Thank you.